Grading tables. So if you're still struggling with this one, let's take a look and go through some of these. So remember, when we're talking about the steps of creating tables, okay, the first one is you've got to pick a variable when you have an equation, okay? So typically, you want to make that pick a good one. So if I look at these first three, okay, notice that I have x with something and y all by itself, okay? So typically, when you're dealing with this, you don't want to have to deal with dividing. So if something's multiplied by x and I pick a y, I'm going to have to divide. And I especially don't want to divide by a fraction, okay? So we draw a table. We label it x and y, okay? I'm going to pick x because that's going to be easier for me. So next thing I do is I pick some numbers. Once again, we want to be smart about this, okay? We want numbers that'll help us, not numbers that'll make it harder. And depending on what you're dealing with, sometimes some numbers are going to be harder than others. For this one, typically I like numbers like -1, 0, 1, 2, 3, okay? That's what I like. So I've got my numbers picked. So now I take the picked numbers, those, and substitute for the variable, for the picked variable, and solve for other variable. Okay? And I do this, I do this as many times as needed, so repeat if needed. And what I want to find is the pattern. Once I have pattern, then I use the pattern to fill out the rest. Okay? So, step 3. So we've got that guy right here. So I'm going to rewrite my equation, and instead of x, I'm going to substitute -1 in for x. Now, I like to put mine in parentheses for 2 reasons. The first, whenever we have a variable next to a number, we remember that number is the coefficient, and it means how many times we have that variable added together, or in other words, it means multiplication. Okay, that we are taking this and we are multiplying 5/2 by x. So if I replace x with something else, I have to remember I've got to multiply here. So that's why I use parentheses. First of all, it shows me that I put this in here from the x. Second, it reminds me that I'm dealing with multiplication. Okay, so I get y equals -1 times 5/2 is -5/2 plus 5. Now, a lot of you may not know how to deal with this, so use a calculator. Okay, that's fine. Let's just figure out what the answer is. So, -5 divided by 2 would be -2.5, plus 5 would give us a positive 2.5. So there's our first set of numbers. So in this situation, in this pattern, -1 and 2.5 are connected. Okay, so now I'm going to do the same thing with my next number, 0. And I like 0. That's why we always want to pick 0. Because 0 times 5/2 is 0. So we get y equals positive 5, which I can get rid of that positive, right? And just have 5. There's my second number. Now, going from 2.5 to 5, we could add 2.5. So that might be our pattern, but let's use one more number just to check. Typically, you want to at least use 3 numbers to double check. Okay, so now we do 1. So 5/2 times 1 is 5/2 plus 5. Okay, we know, or we could figure out that that's 2.5 and do it that way. The other way would be to say, okay, 5. If 5 is a fraction, it's 5/1. To get it to have the same denominator, I would need the 1 to be 2. So I'd have to double the 5 as well. Okay, to get 10/2. Or I can just think this way. What number as a fraction would equal 5 that would have a denominator of 2? Well, it's got to be 10 divided by 2 would equal 5. Okay, and if I did it that way, I'd have 10/2, add them together, we'd have 15/2, which then I could make 7 1/2 or 7.5. Same way. Doesn't matter which way you decide to do it. You'll get the right number. Ooh, that's a 5. Just make sure you write it in correctly. Now, to get from 5 to 7.5, I'm still adding 2.5. So yeah, that's my pattern. So the next number would be 10, then 12.5. And voila, we're there. Okay? So, now we're going to do it for number 2. Okay, number 2 is a little bit easier because I don't have a fraction in front of that x, huh? So I draw my table. I pick my variable, pick my numbers. I'm just going to go 0, 1, 2, 3 this time. Okay? Then I plug my numbers in, so y equals, so x becomes 0, minus 3. 0 minus 3 is still negative 3. So my first number, negative 3. Then I do it for the 1. Y equals 1 minus 3. 1 minus 3 is negative 2. So y equals negative 2. Okay? So my pattern looks like I'm adding 1, doesn't it? Let's test it. Y equals, so if I'm adding 1, this should be negative 1. If we plug 2 in for x, this 2, minus 3 is that negative 1? It is, so that's my pattern. So I know 3 would equal 0. Okay? And there we go. So moving on to the next one. Okay, this one's a lot like number 1, but here I'm going to talk to you about how picking the right numbers makes life a lot easier. Okay? So I'm going to look at this. I've got my x and my y. Okay? So now notice my fraction is 2/5 times x. I want to choose x. Okay? That's the one I'm going to choose. So what times 2/5 will stop me from having a fraction? Okay, well, it's 2 divided by 5, so the opposite would be timesing by 5. Okay, so I can pick a negative 5. I can pick a positive 5. I can also pick 0 because that gets rid of my fraction too. That's one I like as well. But what about one more number? Well, it looks like we're counting by 5s here, right? We're adding 5 each time. So if I added 5, that would give me 10. So let's test it out. Okay, so I get y equals 2/5 times, we start with negative 5, plus 1. Okay, so 2/5, 2 divided by 5, then times negative 5. Well, the 5s would undo each other. So I'd have negative times 2, so just negative 2. If you don't believe me, type it in a calculator. 2 divided by 5 is 0.4. 0.4 times 5 is 2. Because it's negative 5, it becomes 2. Negative 2 plus 1 gives us negative 1. A lot nicer number to deal with, right? Okay, then we do it for 0. Y equals 2/5 times 0 plus 1. 2/5 times 0 is 0, plus 1 gives us 1, so y equals 1. Then we go y equals 2/5 times 5 plus 1. Those would cancel, leaving us 2 plus 1, which is 3. Okay, so it looks like I'm adding 2 each time, aren't I? So my next answer should be 5. Let's double check. Y equals 2 over 5 times 10 plus 1. Now, if we made that a fraction and timed, 2 times 10 would be 20. 20 divided by 5 would give us 4. 4 plus 1 is 5. Another way to think about that is to think, okay, 10 is like 2 times 5. So if I get rid of the 5s, 2 times 2 would still give me 4. So there's multiple ways to deal with these guys, okay? Just that's what I'm trying to highlight here. Okay? And there we go. Now, what if you did your table different and you did 0 or like negative 1, those guys, okay? So I'm not going to show you the step-by-step. I think you guys can do that on your own. But let's just say, for example, you went negative 1, 0, 1, 2, 3, 4, and then 5. Okay, you probably didn't go that far. So negative 1 would be 2/5 times negative 1 would be 2/5 plus 1 would give us 1.4 or 7/5. Okay. Then 0 was still 1. Okay. 1, if we did that one, oh, I did actually wrong, didn't I? This one should be 1.4, huh? That would have been a negative 2/5 plus 1, which would have given us 0.6 or 3/5. And this was 7/5. Okay, if I do 2/5 times 2 plus 1, I get 1.8. Okay, so as we're looking at this, we're adding our pattern 0.4 each time. If I keep adding 0.4, I would get 2.2, then 2.6, then 3. See, it still matches up. The pattern on the left is just adding 1 each time, whereas the pattern on the one I did was adding 5. So it's still going to work out, okay? Still going to work out. Alright, now let's clear some space. Now let's take a look at number 4. The rest of these are a little trickier, aren't they? Okay, because our problems have gotten more complex. Okay, the difference with these ones is that now the x and the y are on the same side. That's the only difference. Okay, they work just the same. Pick our variable, x, y, I'll pick x, 0, 1, 2, 3. We take our equation, instead of x, we put in our number, just like we did up on these guys, okay? Same process. The only difference now is, to get y by itself, I've got to get my numbers together, okay? So, 0 minus y would still be negative y, so negative y equals negative 1. Now, can we keep negative y? No, y has to be positive. So, to do that, we want to get rid of the negative, so we times by negative 1. Because that wouldn't change the y, it would leave the y as y, but make a negative positive. But if we do it to one side, we also do it to the other side, so we end up with a positive 1. And there's our first one. So then we just do the same thing with our other numbers. So instead of x, I put 1 minus y equals negative 1. Now I've got to get rid of that positive 1. Well, how do we get rid of a positive 1? We subtract 1. Because of the equation, I have to do it to both sides. That becomes 0, which we already know what happens here. So we get negative y equals negative 1 minus 1 is negative 2. We times everything by a negative 1, and we get positive y equals positive 2. Okay, looks like I know my pattern. I'm guessing that this one's going to be 3, but let's check it out. So 2 minus y, I plugged in for x, 2 equals negative 1. To get rid of a positive 2, I subtract 2. So negative y, because we can't get rid of that negative even though that disappears. Negative 1 minus 2, negative 3. What happens when they're both negative? I switch them to both positive by times them by negative 1. So there's my pattern for that one. Okay, so number 4, or I guess number 5, same idea. Okay, same idea here. Okay, I've got 4x minus y. I'm going to choose x again. Pick some numbers. Plug in. Instead of x, I put negative 1 in. 4 times negative 1 is negative 4. Still minus y, still equal to negative 5. To get rid of a negative 4, I'm going to add 4. Because of my equation, I have to do the same thing to both sides. Okay, so I end up with negative y equals negative 5 plus 4 is negative 1. Times them both by negative 1 to get a positive 1. Then we do it for 0. 4 times 0 minus y equals negative 5. 4 times 0 is 0. So we get negative y equals negative 5, right? Because we can get rid of that 0. Times them both by negative 1. We get positive y equals positive 5. Okay, looks like my pattern is adding 4. Let's verify. So this should be 9. So 4 times 1 minus y equals negative 5. Positive 4 minus y equals negative 5. Got to subtract a 4. We get negative y equals negative 9. They both become positive when I multiply by a negative 1. So yes, it's 9. So I know that this one's got to be 13. Okay? So then number 6, we look at it the same exact way. Okay, same exact way. This one will have kind of another extra step to it though. So number 6, 6x minus 5y equals negative 10. So we pick our variable. Okay, I'm going to go with x again. Now this one's kind of a trickier one. Now we can try to decide what numbers are going to work better, but with this one it can be tough. So let's just dive into it. Okay, so I go 6 times negative 1, okay, minus 5y equals negative 10. So 6 times negative 1 is negative 6, minus 5y equals negative 10. We add 6 to both sides, giving me negative 5y equals negative 4. Divide by negative 5, and we get y equals 4/5, which, if you needed the decimal, is 0.8. Most of you guys like the decimal, but the fraction can be nice too. Okay, now we do the same thing, but with just a different number. I want you to see that it's pretty much going to end up being very similar. Okay, the process. So we do 0. 6 times 0 is 0. 0 minus 5, so we don't have to do any of this part. So we end up with negative 10 here. And divide by that, we get positive 2. Okay, or we could have also written 10/5. Why would you want to do that? You'll see. Okay. Alright, now the next one. So we do 1. 6 times 1 is 6, so we'd have to subtract 6 to both sides, getting us negative 16. Now we'd end up with negative 16 over 5, which is positive 16/5, or, for those that like the decimal version, 3.2. Okay, now you should be able to notice the pattern here. Okay, 0.8 to 2, we'd add 1.2, right? 2 to 3 would give us, we're adding 1.2. So 4.4 would be the next, because 3.2 plus 1.2 is 4.4. Okay. Also, notice if you did it by the fractions, the denominator is always 5, and we go 4, then 10, then 16, so we're adding, so it would be 22 over 5. 22 divided by 5 gives us 4.4. Okay? Now, the thing to remember, some people want to combine those and would have made that one y. Remember that negative 5y is saying negative y minus y minus y minus y minus y. Right? There's 5 of them. That's why 5 is the coefficient. 6 is a number. So I can't subtract y's from 6. That's why it doesn't work. Okay? That's why we can't combine them. Whereas negative 10 is a number, just like the minus 6, so those can be combined. Okay? Now, 7 and 8, same idea. Okay? I'm going to show you 2 different ways you can deal with them. The first way on number 7 would be, couldn't we add 2y to both sides? So we'd end up with 2y equals x plus 10. And then we could build our table? Yeah, we could do it that way. You could even divide everything by 2 and have y equals 1/2 x plus 5 and do it that way. Okay? I'll just leave it at this one. Okay? So pick some numbers again. Now, if I'm looking at this one, okay, I have just a regular x, and I have an even number. I'm going to divide by 2. If we want nicer numbers, let's count by 2's. So 0, 2, 4, 6, because that's going to give us nicer numbers. So 0 plus 10, we put 0 in for x. We get 2y equals 10, divide by 2, and y equals 5. We do it with a 2. 2y equals 2 plus 10. 2 plus 10 is 12, equals 2y. To separate, we divide by 2. Y equals 6. Okay, looks like I'm adding 1, so I'm guessing that's going to be 7. Let's check it. 4 plus 10 would be 14. So 2y equals 14, divide by 2, and y would equal 7, which is true, making that one 8. Okay, so you can mix things up. Now in number 8, you could do the same thing. However, I'll show you what we do when it's just the way it is. Maybe. Okay, so build my table. x, y. We can choose -1, 0, 1, and 2. Okay, so now I'm going to plug it in, so I write 0 equals 3 minus 3y minus 3, but instead of x, we put in our number -1, right? We take this, substitute it in for x, which looks like this, and we're dealing with multiplication. So 0 equals 3 minus 3y. 3 times -1 is -3. Minus a negative is plus, so it's really plus 3. Okay. Now this 3 and this 3 can't be combined with that, because that's the coefficient, right? But these are both numbers, so 3 plus 3 would give us 6. To get the 6 away, because we can't combine them, because 3 right here is our coefficient, 6 is a number. So we subtract to make that 0, so we're left with -3y. Remember that minus stays with the 3, and we think of it as a negative. 0 minus 6 is -6. Then we just simply divide by -3, and we get a positive 2 equals y. Okay, there's our first number. So it's the same process, just adding a little more to it. Okay, so 0 equals 3 minus 3y minus 3 times 0. So that cancels. 3 minus 3y equals 0. Subtract 3. -3 equals -3y. Divide by -3. And we have positive 1 equals y, because negative divided by negative is a positive. So it almost looks like we're just subtracting 1 each time, doesn't it? Let's double check it. 0 equals -3y minus 3 times 1. Whoops. 3 minus 3y minus 3x. There we go. Missed a term, didn't I? So 0 equals 3 minus 3y. Then -3 times 1 is -3. 3 minus 3 would be 0. That eliminates that. 0 equals -3y divided by -3. 0 divided by anything is 0. So we get 0 equals y. So the 2 would be a -1. Okay? So there's the front side. Now I think it's easier to go from a story problem to a table, right? So let's just bust through these ones. Let's make my tables. Why am I deciding to do it this way? I don't know. Just felt like it, I guess. Maybe give you guys a second to breathe. All that math probably making you hyperventilate or something like that. Okay, so for this, it's kind of the same idea, the same step by step. So the first thing we need to do is we need to pick our variables. With story problems, I like to think of them as unknowns. And I think about them as they've got some sort of connection. Okay, they connect somehow. That's our first step, just like with the other one. So I look at number 9. Ignatius is looking into adding to his Ninja Pony collection. He currently has 273 Ninja Ponies, all different characters, but he would like more. With his allowance, he figures that he can buy 3 every month. So, what are our unknowns? Okay, well, I guess our unknown is how many more ponies is he going to buy? Okay, we don't know that. So that's going to be one of the variables. His ponies, how many he's going to buy. Okay, and what is that connected to? Well, he's going to buy 3 every month, so that's going to affect how many ponies he has, so we're thinking months. Now, which one affects the others? As the months change, as we add more months, he's going to get more ponies. So we think of the months right here. Okay, and the ponies on the right side. You can also call them just like M and P, same thing. Okay, so we think about with story problems, okay, I guess step 2 is pick your numbers. I like to always start at 0. I think of that as my starting point, okay, and then from there we just make our pattern easy to deal with. Okay, then step 3 was we plugged them into the equations. So step 3 here is you find growth, you find how it's changing, growth, change. And then you repeat that as necessary till you fill your table up. Okay? So, looking at this, we know that he's going to buy 3 more every month. That's our growth. That's our change. Well, where did he start? He started with 273. So before he started buying more, he had 273. Then the first month happened, he bought 3 more, which would give him 276. Then the next month, he bought 3 more, 279. Next month, 282. Okay, and so on, as far as we need to go. Alright, that's basically all we got to do. So the trick sometimes is finding that connection. Once you have it, usually it's fairly easy. Okay, so 1, 0, 1, 2, 3, 4. The average person spends about $1,200 eating fast food per year. Okay, so we've got this per year. So every year we can see how much we've spent. So this would be year. This would be spent. Those are our variables. Okay, so when we first start off, we wouldn't have spent any, right? But after the first year, we would have added $1,200. Then the next year, we would have spent the same amount more, so that'd be $2,400. The next year, $3,600, and so on. And then $4,800. Okay, so you can see that. Alright, now, I'm running out of time here, so we're going to kind of hurry through the rest. So Horatio is saving up for college. He already has $10 in his bank account. He recently scored a new job testing out chairs and will receive $5 for every chair that he tests. Okay, so we want to know how much money he has, right? Okay, in his bank account. How much has he started out with? 10. How is he getting more money? With his job. And how does he get that? For every chair he tests, he'll get more money. So 0 chairs before he started his job, $10. After the first chair, well, he gets to add $5, so 15. Second chair, add 5 more, 20, and so on. And you could keep going with that one. Okay, 12. Bethany likes collecting fingernails. Her collection is growing quite large. She currently has 72 different people's fingernails. She collects, on average, 3 a day. So, she wants to know her fingernail collection, okay? So this would be fingernails, okay? And she's collecting them every day, so that'd be day. So how many did she have already? 72. Now for every day, she's adding 3 more. So that would be 75, then 78, right? Do you see the pattern? Then 81, then 84, and so on, okay? Now, moving quite along, 13. The zombie apocalypse is upon us. The CDC has reported that in the city of Tooele there are 50 zombies already, with the population of zombies doubling every hour. So what's being affected here? We're having more zombies created, right? When are they being created? Every hour. So we've got hours here and zombies being created. Okay? So when they first started off, first reporting, we already had 50 zombies. Okay? Then every hour, it's doubling. Doubling in math is times by 2, so timesing by 2 would be 100. Timesing by 2, 200. Timesing by 2, 400. Timesing by 2, 800, and so on. Okay? Now the last one. The Super Amazing Contest of Awesomeness has begun in Mr. Rydalch's class. The contest is single elimination. There are 59,049 contestants starting the competition. Every day, 1/3 will be eliminated. Okay, in our last minute. So, every day, we're losing contestants. So, in the contest. So, we'd have contestants. So, we started out with 59,049. The next day, we're going to cut that down by 1/3. So I take that and I divide by 3. That gives me 19,683. Divide that by 3. For day 2, 3, and 4, that gives me 6,561. Then 2187. Then 729. Okay? And if we kept going, day 5 would be 243, then day 6, 81, day 7, 27, day 8, 9, 3 on day 8, and then we move down to 1 on day 10. And there we go.